which makes it like really weird. It's like how is that supposed to say that? But they're trying to
That's like it's not over.
well, yeah, so that's right. There's still like
All right, guys, it's 7:30, so we'll get started. This week we'll be learning about abstractions. This is lecture number 4. So before we start, a few announcements. PA3 is due on Wednesday at midnight. Always remember to double check your route spelling. It's a big issue you see on Ed. Either you forget like /API or you forget a trailing slash, or it changes from /users to /user. So yeah, make sure to double check the routes. Also, make sure to test in Postman before running the test script, especially if you're having issues with the test script and you can't really figure out what it is. Testing in Postman, it really allows you to pinpoint what the issue is. So Postman is really useful for debugging anything that you can't figure out from the test script. And lastly, follow the file submission format in the assignment exactly as we show. And so this means removing PyCache and also removing that Vem folder, because that requirements folder or that requirements file we give allows us to recreate the Vem folder, but exporting the whole Vem folder has too many files in it for it to be efficient to do it that way rather than just giving the requirements file. Okay. We'll quickly go over some review for the last 3 lectures. So if you remember, we have a SQL command, and that's given from the server to the database, and the database sends data back to the server. We also have relationships. This is what we went over in the last lecture. And so this relates data to other data in a very structured manner. And we use foreign key columns to create these relationships. For one-to-one, one-to-many, and many-to-many, they'll all use foreign keys just in different ways. If you remember, one-to-one could be like users and then a profile, where every profile is one user and one user has one profile. One-to-many, common example is an album with songs. Many songs can be part of one album, and one album can have many songs. And then a many-to-many could be like clubs that you're part of on campus, and then students. A student can be part of many clubs, and then many clubs can have many students in them. So those are the 3 types of relationships that we went over in the last lecture. If you remember, this is what the tables might look like. Each table has its own ID field. And in this case, this is a one-to-one. So here, the user ID field in profiles references a specific user from the users table. So you can see the 10 is for Joyce, the 20 is for Mateo. In this case, we have a one-to-many. So this is like what I was saying with albums and songs. So the album ID in this case is the foreign key, and that will reference exactly the album that the song belongs to. And then lastly, the many-to-many. If you remember, we need a join table in the middle, because one way to model students in courses, whenever you think that you might need a list to model something, that usually means you need another table, because we don't want to use lists because inserting into a list takes a long time, whereas adding an entry to a join table is really easy to do. So if we wanted to add a student to a course, we would just be adding into the join table. And the join table gives us all the information we need to relate one student. Like we can say Joyce with her net ID JYW55. That student is in 2 courses, and those courses have their own specific titles. And then if you want to add something, like if I wanted to enroll in this course here, CS 1998, I can just add that one entry to the join table, and that makes it really easy and quick to create this many-to-many relationship in a structured manner. And so obviously we wanted to move from storing data in Python to storing it in SQL, and that was because Python had its set of drawbacks, but SQL also has its own set of drawbacks. So just to go over the few main points, one is lower code readability. If you read SQL code, it's extremely hard to understand, especially once you get into like very big queries where you have many wheres and ands and ors. So the readability is just lower when you're just using plain SQL. Also, it used to be susceptible to vulnerabilities. This is no longer the case, but it's still really interesting. So I'll go over in this lecture about how SQL used to be susceptible to this and why the abstraction will help get rid of this one pain point of SQL. And lastly, your runtime exceptions are not handled really well. Usually if you have an error, it'll just like spit out some error, and it's kind of hard to actually figure out where that error comes from or what's causing the error. So just to go over that first point, readability. Can any of us tell me what this means here? No, right? So this is like extremely hard to read. And it's really just like honestly only using a few keywords. But yeah, the readability is like a big issue with just raw SQL. And that's even when you do capitalize the keywords. And so most people may not even do that. And it gets even worse to try to read this. So abstraction is one way that would help alleviate this issue here. Secondly is the vulnerabilities with SQL. And so have any of you guys ever heard of SQL injection? Yeah. So SQL injection is it's like a craft in order to input to it's crafting an input to try to trick SQL semantics in a malicious way. And so it's like allowing a database to access allowing database access to a malicious external source. And so someone that isn't supposed to be getting access to something crafts the SQL in a specific way. They might be able to query unauthorized data or even corrupt or delete existing data. So one example I'm going to walk through here is trying to break a login site. And just as a reminder, this is all kind of been patched in SQL. This isn't still the case where you can exploit this. But with abstraction, it takes one layer away. So users don't know that if you're using SQL, if you use abstraction, you're not directly using SQL. So it's harder to like find what can actually break the code that you have. But this is one example of what would break, we can say, a login. So you try to enter an email and a password. And this might be what our actual SQL code would look like. Let's say someone put in that email, that password. We're trying to say select everything from the user where that email exists in our database, and that's the password in our database. So if both of these are wrong, then it would evaluate to false, and in which case the user would not be able to log in. Even if the email is right, it would still evaluate to false, unless the email and the password are both correct. The user will not be able to log in because we need both of those to evaluate to true. Does everything make sense up until this point? Okay. And so then there's also this malicious query that we can have. So instead of putting in this email and this password, we can instead put in this really weird password here. But what this is going to do is it's going to insert into our SQL exactly as we see here, where XXX is just like some placeholder characters, and you have or 1 equals 1 with a semicolon, and then dash dash closing bracket is actually the notation to just like ignore everything that's on that line. And so that's to make sure that the double semicolon doesn't actually break the SQL syntax. So it ignores whatever's after that. But what's happening here is it's saying if the email equals the email and the password equals that, or 1 equals 1. So how will this actually evaluate? Where if email equals email is false and the password is false, that and or 1 equals 1 will be true. This ends up being false and false or true, which simplifies to false or true, which simplifies to true, and then someone ends up getting access to the database without actually having the correct password or email. And so that's one case of like a possible vulnerability with just allowing SQL to be directly inputted into your database. And so now we introduce object relational mapping. And so this is the level of abstraction to move away from SQL and into using your own language. Like in this case, we'll be using Python and still be able to write SQL code using this relational mapping. So what it does is we create objects as abstractions. So instead of querying and manipulating data, just writing raw SQL, you're actually manipulating the data using these objects that you create. And so you're still able to preserve the database for SQL and the storage benefits of SQL. But it allows us to reason about entries as instances of an object, which we're all comfortable with from any like CS1110 or CS2110 that are object-oriented languages. And so it also allows us to keep all our code more consistent if we're using objects throughout, rather than switching between Python and SQL. So on the left here, we have what we would normally write in SQL. And on the right here is one example of an ORM. And so there's many different types of ORMs. They all look a little bit different. This is just like any generic one, what you could specify and what it might look like. So instead of creating a table of users, you create a class users, and each class has an ID, a name, and an age. And so this might be very familiar to what you guys learned in 1110 or 2110. And this is what an ORM does for us. So the one that we'll be using for Python is called SQL Alchemy. This is a very popular ORM for Python. It comes with built-in query parameters, and it integrates very well with Flask, which we've been using throughout the course. And so there are many benefits to using an ORM. a lot of them come from those drawbacks that we had from SQL, but some of them are that makes the code much more readable, and it's very similar to what we're used to writing, so it closely resembles like our thoughts as we like learn how to code. Also, it's abstract, so it's SQL-free data representation. So no one really knows exactly how our backend looks like. No one can like write code that would break our backend because there's this level of abstraction because we're not using SQL. Also, you can manage your database and application using the exact same logic, except you're using the same language throughout all your code, which makes it much easier to manage everything. And there's cross compatibility with other databases that we were using. And then lastly, secure against SQL vulnerabilities, which, as we said, aren't an issue anymore, but still that level of abstraction allows people to not exactly know what might be going on in the background. Does anyone have any questions about this? Okay. Of course, there's also going to be some ORM drawbacks. So some of them, and the main one is going to be that you have slower query performance. And this is especially true when you get to really long queries. A lot of times people say that some ORMs won't even be able to make every SQL query that you can make just using raw SQL. So yes, writing raw SQL is the more efficient way to do it. And using an ORM might make the code simpler, but might offer some performance drawbacks. Additionally, it'll increase your application code because you have the SQL as well as the abstraction code. So overall, your application becomes more dense with code. Thirdly, you abstract away from the fundamentals of SQL. So obviously, if you want to move your application from using Python and SQL to just Python, it might make it easier for your application and people who just want to learn about what your application is doing. But the nice thing about SQL is that it's also an industry-wide thing. So people that know how to read SQL can just easily look at SQL code and understand what it's doing without having to learn the specifics of the different ORMs that we have. And then lastly, there's a potential misuse because it is too abstract. And so because some things might not transfer from an ORM to SQL directly, sometimes there's that level of abstraction where because you're not writing direct SQL code, something might not work as it's intended to. And so those are just a few drawbacks of using ORMs, but in a lot of cases, it's preferable to use it. I would say the one time where people might keep SQL code inside an application is when you do have a really big query and you really are just striving for the best performance you can get. And so in that case, writing a raw SQL is the best option, and there's really nothing else that will compare to that. Does anyone have any questions about any of these drawbacks? Yeah.
Can you explain the maximum potential for misuse because too abstract?
Yeah, so because these ORMs are built in a way that tries to map what you're doing using an object to SQL, if there's ways that these ORMs are written, either that's not documented correctly or there's just assumptions that they've made that isn't exactly explained, there's potential for misuse where you try to use one of these ORMs and it doesn't work the exact way you intended it to because it's trying to mimic SQL using these objects and it might not do it perfectly, and every ORM is written in its own way, trying to do it the best they can, but it might not end up working out perfectly. Great question. Anything else? So lastly, we have, again, our app.py versus our db.py. And so now our app.py, it'll connect to the server to a client. It defines all the routes and responses, and it handles all the logic and operations. And our db.py, if you remember, it connects the server to the database, defines the tables and its columns, and it's what actually uses CRUD to create, update, and delete, retrieve, update, and delete information from our tables. And so we'll still be using that app.py and db.py even as we move into this ORM, which will change up the way our db.py looks, but the structure of our two files is still going to be the same. So again, we have our client and our server. Client will send a request to the server. The server so then the route is triggered, the data is being operated on, and there's a return response. And then the server actually gives that SQL command to the database. So this is where that switch is from the app.py to the db.py. So if we go back, this is app.py. The request is sent to the server. Server actually manipulating the database, that's db.py. So SQL command goes into the database, the data comes out of the database. The server needs to communicate a response back to the client. And so that's again on the app.py side. Okay. Any questions about anything we went over today? All right, then we can move on to a short demo for today.
Okay, so yeah, you should see the demo starter code here. Okay. Yeah, I'm recording. Okay. So yeah, let's go over is everybody ready? Is anyone not ready? Okay. So we'll just go over like the basic setup stuff again really quickly. So once you've downloaded the starter code, oh yes. You can go into the folder. And then here I'll make my virtual environment, which remember is the command python -m vem vem python 3 -m vem vem. Okay. And then to activate it on a Mac, it's source /vem bin activate. And then once you see this virtual environment sort of flag there, you should be good. Again, on Windows, I believe it's scripts like / like something activate with like the caps on it. But yes. Then we can go and install our requirements. pip3 install -r requirements.txt. Okay. Is there anybody who hasn't installed the requirements yet? And also, just as a note, if anyone needs like any help, the TAs are up here for you. So yeah, feel free to, like, if it's like something with the code, feel free to raise your hand and they can come and help. Okay. If not, let's open the code for today. Okay, so today we still have an app.py and a db.py. But let's do some, well, first walk through app.py, and then we'll notice how db.py is like a little bit different than the db.py that we like have worked with in the past. But first, let's walk through app.py, right? So essentially here with app.py, there's some general like setup stuff at the top to, I guess, like set up the ORM that we're using in terms of SQL Alchemy. So just to briefly like go run over it again, how essentially it works in code is that now we're no longer using SQL, but we can represent these like entities in our database as objects, such that we can like use more familiar like object-oriented programming that you would learn in like a lot of your classes to program a lot of these backend operations rather than using raw SQL commands. And one of the reasons why this might be more helpful for us is if you remember from the previous like I guess like demos and your assignments where we've used SQL, one like very obvious like flaw there is that when you type in the SQL code, remember how we like imported the SQL code as like a string into like some like like db.do function to ask our database to do that. But when we type that string, none of it is like syntax highlighted for us, right? It was all just like green, which is like very unhelpful for us if we, for example, potentially like make a mistake somewhere and like make a typo. So even just for that reason alone, an ORM can be like pretty helpful for us here. But before we move into that, let's like walk through the specifics here of app.py. So here we just have, stuff that we're importing. We're importing JSON, which is our request, importing stuff from like our DB file, and then importing our framework Flask. Here, this first line, essentially we're just defining the name for our database. Today we'll be further developing on our to-do app. So it's still going to be called to-do.db. On line 8 here, we just have an instantiation of an instance of Flask. So just to like start up our app essentially. And here are some just things that configure our ORM, which is specifically like SQL Alchemy, right? So this first one here, database URI, is essentially just telling them like to specify the exact SQL library that we want to use. There might be like a bunch of different variations on like SQL database. So this first thing here, we just put SQLite because it's like the specific variation that we want to use for our particular app. And then over here, it's just the DB file name, which as you see is like the variable that we've instantiated above, just to say that this file is going to be our database file. Next is SQL Alchemy track modifications. This is something kind of like quirky. It is not like super related to what we're doing. We're just setting it to false to like sort of minimize like resource usage. But essentially what it is that like SQL Alchemy has this sort of like event listener system where they can like track modifications you make, I guess, like in the file and to like your database. We just set it to false like by default here. You can set it to true to actually like, I guess, like listen to these events, but it is a little bit like resource intensive. And for our like smaller app here, we don't really need it. So we set it to false. Then finally, we have echo. Echo is pretty useful for us because it's just like, now we're not running like raw SQL commands, right? We're actually running like Python code. But maybe we want to know like what exactly our Python code translates to in terms of raw SQL. And that's what this SQL Alchemy echo field sort of does for us, such that when we run commands in our app, like we enter requests into our app and the SQL code or the Python code is executed, it'll print out for us what the corresponding SQL code is, which is pretty useful, maybe for like debugging purposes to see if you're actually doing the thing that you actually want to do in your database. Next is just initializing our app. And then this function here then essentially creates all of our tables. Okay, so another thing that's really important to note that is a change from the previous demos and assignments is the use of success response and failure response. We briefly went over it in the last demo where we did it also in PA3, but we can go in, we're going to be jumping into it in like a little more detail here just to like clarify a few things, right? The reason why we want to have this success response and failure response is, well, just there's more for like code cleanup purposes. We return some kind of like JSON object every single time we like look for a response from our backend, right? And it's a little bit redundant to write like JSON.dumps something and then like the code every single time. So we just do this to, first of all, make it like easier for us. And then second of all, to like provide a default. So like if we're just doing something like very vanilla and like neutral, we don't have to like add anything, and it like simplifies it for us. Just in case anyone isn't like familiar with like a default argument in Python, it's essentially, for example, this second entry here where it says code equals 200. What it just means is that like if I provide an argument for this parameter, then it'll take in that new argument. But if I don't provide an argument for this parameter, then it'll just do 200. So let's just like take a look at it here. Make a new terminal. Okay, so if I just like start Python 3, let's say I make some kind of like function. So print code and code equals like 200, for example. And let's just like print the code. So yeah, when you're in your Python interactive shell, you can just define like a small function like this. Let's just say like print code like 40, right? What would we expect this to print? Yeah, 40. Okay. What if we just do print code? Yeah, it'll print 200, right? Because we haven't provided a parameter for it. So that's essentially what it does. Note that for this error one, the message parameter is actually like necessary because you want to like know what the message is. So it won't like just like default to anything. Okay. So that's basically it for the setup for the app file. And the rest of it is just like the endpoints. So does anyone have any questions on the app file before I move to the database files? Okay, if not, let's take a look at db.py. And I'm just gonna open another one for comparison. Oh, never mind. There's nothing to compare because there's nothing in here yet. Okay, we'll pull that up when it's like helpful and necessary for us. But essentially, in this like database file, what we're going to do is we're going to implement like a couple of models. So instead of representing actually like implementing that SQL code and like asking SQL to like create tables for us and all of that, instead what we're going to do is just define Python classes here, because we're going to use like classes or like objects to represent entries in our database. So yeah, we'll hop into this. This essentially just like initializes an instance of like SQL Alchemy for us. Does anyone have any questions before we start? Okay, let's get started then. So the first thing that we have in our, I guess, like to-do list sort of app thing here, we're gonna have tasks, right? If you remember from the previous lectures and like assignments, we were creating like task tables. This time we're going to define a class called task. It'll take in a parameter db.model, which is just like, since we know that db is an instance of SQL Alchemy, we're basically telling SQL Alchemy that a task is essentially like a model in our database. To further clarify on like what exactly like a model is, it's just going to be like a blueprint of like the objects that we're going to be making. So you can think of it as like either like a blueprint of like that specific object, or you can think of it as like a blueprint for a specific row in your database, right? So now, because this is an object, instead of like actually defining each column and stuff, can we maybe think of like what instead might, represent an attribute of this particular entry in your database? Like, for example, if I want to know like, if this task is like done or not, what might it be for an object? Any guesses? Oh, yeah, in the back. Yeah, exactly, right? So instead of like defining the columns, now they're just going to be like properties or like attributes of our object, as we might have seen in like 11.10 before. But first, like let's just create some documentation for this particular class. So this is just like the task model for now. We do need to define like a couple of, so basically the logic here is that we're just going to be defining fields that represent like columns, right? There are some other things that like logistical things that we need to define as well, just for I guess like our program to kind of know that this is going to be like an entry in our database, for example. So first we need to define the table name, which is going to be task. And then, so instead of like when in here, this is the last database.py that we did in demo 3. So here, let's do like a comparison, right? So here we've created table tasks and pulled up like the IDs. We pulled up like the columns in terms of like the ID, the description, and the done. We're going to do the same thing here, but as attributes, right? So ID equals, and the way that we tell SQL Alchemy that this is going to be a quote unquote like column in our database is just with db.column. And then in the actual like arguments that we provide this like db.column function, we give it the properties of this particular column. So here we said it's an integer primary key and auto increment. So here we're going to tell it that this is a db.integer primary key equals true. And then perhaps a field called like auto increment equals true. So the nice thing is that like, SQL Alchemy, because it recognizes that it's supposed to like model a database, it has all of these like attributes already prepared for us. So we can just, flag it to be like true or false rather than having to like define all of it ourselves. Okay. And similarly, we're going to have description. I'll get rid of this Explorer so we can. Which is again, column. So here it's going to be a string. And then here we ask that the description be like not null, right? So we're going to say nullable equals false. And the next we'll have done, which like somebody said before, is just going to be like the Boolean representation of whether or not it's actually done. So we have db.column, db.boolean, nullable equals false. Okay. Does anybody have any questions up to that point? Okay. So the next thing that we need to do if we have like some object, right, is we need to be able to initialize that object somehow. So with every like Python class, we have like the $_init function that essentially allows us to like instantiate a class, instantiate like an instance of that particular class, right? So let's do that next. So init, and remember init takes an argument self. And now we're going to give it a unique argument that we haven't really seen before in this class. It's called kwargs. And what kwargs means is just like a concatenation, abbreviation, something for like keyword arguments. And essentially what it does is that it allows you to like enter any sort of parameters in there, and then it will turn it into a dictionary for you. Can anybody guess why that might be useful? Well, I guess before we like talk about why it might be useful, let's do like a quick demonstration as to like what it looks like, so then we can guess why it might be useful. Okay, so we'll Python 3 again. We'll just define so we'll define demo, and then this takes kwargs, and we're just going to print kwargs. Okay, so let's say we input like demo name equals Joyce, mood equals happy. We see the output is like a dictionary of the things, the parameters that I inputted. With this in mind, why might it be useful to like have something like this? Oh yeah.
Maybe once the user to type in any number of like arguments, like pass a number of arguments to their function, because you don't really know the number of arguments that the person might pass in. So you want a person to be able to pass in any number of arguments to the function. Yeah,
that's a great answer. So when we have like things like this, if you remember from like our previous demonstrations and whatnot, some potential like things let's say you like define some kind of like object that just takes in like a bajillion parameters, right? It's going to be a hassle to like define all of those, and you might not know exactly how many somebody might put in. So if you give them this freedom to like put in what they need to like define this specific like object or the specific entry in the database, once you have it in this like silly little like dictionary form, you have like very easy functions like dictionary operations to access each of the fields here and get the information that you need. Which is why this, I guess like this feature here is going to be pretty helpful for us. Okay, so yeah, let's do the init function. Oh yeah.
Yeah, so the init, when they give their keywords, is that like more columns than the one that you already find about like the item description and drawbacks, and it's easier adding more columns and stuff?
So like it's possible that they might like enter in more things, right? But then in our init function, we're going to just like retrieve the things that are like useful for us. that we kind of like wanted to find a particular like entry with. Okay. Okay, so here, the way we like define like a particular field in Python is table name equals. Okay. Okay, the way we want to define a thing in Python is self.description equals kwargs.get. So the output of that thing is going to turn us into like a dictionary, right? So we're going to be able to just use like a traditional dictionary like get to actually retrieve the thing that we want. Just in the description. And then from a long time ago, we kind of talked about like when we use the get kind of functionality, we can also set like a default value here. In the case that they don't actually provide us a description, we can't find anything with the key description, we can just give it an empty string, which is like the default. And then similarly, we'll do the same for done. Self.done is kwargs.get done. And then we default to false because if they don't put in true, like that probably means they haven't started their particular task yet. So we'll do false. Okay, any questions here? Okay, if not, we'll move on to the next function that'll be useful for us when we're defining these like models in our database, which is a function called serialize, which also takes in self. Okay, so what does serialize essentially do? Now that we're representing like each entry in our database as a Python object, it's gonna be we're still gonna need it to be able to like send a response to the front end in some way that's more like digestible and like processable for them, right? Since they're not just like entries in our database anymore, it's not just like fields that we can just like pull out and stuff like that. But we'll still be pulling them out, but we'll have to like pull them out like from like the Python object, right? We can't just send the front end the entire like Python object because then like it might not be like compatible for them, or they might not know what to do with it. So we just need to turn our Python object into the easily like readable and like digestible JSON format that we've always been using, which is what this serialize is going to do. So essentially, we're just going to return some kind of like dictionary that represents this object that we've created. So we'll return like a dictionary where the ID is self.id. The description is self.description. And then the done is self.done. And this is something that once we call, we can put into that JSON.dumps function that we've always been using to turn it back into a JSON and send it to the front end. Yeah, so that's basically our initial implementation of the task model. Does anyone have any questions there? Okay, if not, we'll move on to the subtask model. So remember that from like our last assignment, we now have like two entities in our app, right? We have the actual task themselves, and then we actually have a subtask as well that was in a relationship like with our tasks. So we do the same thing, we initialize subtask model. Similarly, we need to define a table name for it. So table name equals subtask. We're going to basically be doing the same thing up here. So ID equals db.column, db.integer, primary key equals true, auto increment equals true. For the description, also something similar. And then since this part's the same too, I'll just be copying the code up here. Okay. But there's one last thing in the subtask model that's going to be different, right? Because we know that the subtask is in some kind of like relationship with the task. And last time we talked about something called like a foreign key that would like link these two entities together. We need to somehow define that here in our object as well. So does anybody remember like what the foreign key in like the subtask model was from like the last time we talked about this kind of relationship? Yeah, so we need to somehow specify the ID of the task that's associated with a particular subtask. So we define a field called task ID equals db.column, db.integer. And here is where we define that it's a foreign key to something, right? So we do db. There's a function called foreign key, which will allow us to define what exactly is going to be our foreign key. So in this case, it's going to be task.id, right? The task that we're referencing here is the table name called task that we've told SQL Alchemy to like instantiate for us. And so task.id, this essentially tells us this is like the column in the two tables, or the column in the task table that we would want to reference to be our, I guess, like foreign key. And then similarly, we want nullable to be false because we need like a foreign key there to actually know which task this one is related to. Okay, and then we'll quickly run through just like the initialization stuff too. So the init function, again, takes self and then kwargs. Here we initialize a subtask object. Similar to above, we just need to like put in like the self.stuff and like essentially create it from the parameters that were given to us. So self.description is kwargs.get description with an empty string as the default. Self.done is kwargs.get done, and then false. And then lastly, we have a new field here, so it's just going to be self.taskid is the kwargs.get the task ID field. And then the last thing that we need is just going to be a serialize function. So the serialize, again, takes in parameter self and serialize a subtask object. And then similarly, again, we just want to, return some kind of dictionary here. Dictionary, where the ID is self.id. The description is self.description. And then done is self.done. Oh, and then we can also return the task ID. Okay, does anybody have any questions on the setup of like any of these? And I guess I'll leave this up here for a bit. Just to make a quick comparison to, for example, what we did here. Notice that this instantiation of like a particular, of like a subclass table and like the entries is a lot cleaner than the SQL code that we wrote here, but it does functionally the same things, but just SQL Alchemy like takes care of a lot of this like, I guess like complicated stuff that we have to define ourselves, but now we can just flag them to be true or false. Yeah, so any questions? Yeah.
If kwargs doesn't have task ID.
Yeah, so if Quark doesn't have a task ID, I think if it doesn't exist, it'll just be like nothing here, right? But that's gonna be like a problem for us. Like that means in the app.py, we're probably going to like define some kind of like error if there's no task ID involved, right? because it wouldn't even work for us in the database that we've defined, since nullable here is going to be set to false. But in terms of like this function itself, if there's no task ID, the get function will just default to like a none object if it can't find it in the dictionary. So that helps us, because then like in our app.py, we can be like, oh, if this is none, then return like the JSON dumps error, like the failure response with some kind of error. Any other questions? Okay, if not, we'll be stopping here for just the basic setup of our database. And then next time on Wednesday, we'll be implementing some of the routes, like the routes you've seen with like tasks, and finishing up the rest with like the subtask as well. Okay, so now we'll be moving on to the Kahoot.